Hi everyone. So now I have talked about DFS, but not about DFS. So you all know DFS stands for depth first traversal. Okay, depth first search. Okay, the depth first search. So what does it means? That means first we are focusing on the depth. And what does that mean? Since so we can say one, two, three, 4, 5, 6. Okay, this is a graph. Okay, and if we do a depth first traversal, so since the name suggests the depth first, so its principle says we need to search inside depth first. Okay, we need to prioritize depth. So since let's say this is our starting node, we'll go to the its depth. Okay, we can go this side also or this side also. I'll start from this depth. Okay, so it goes there. Then again the depth of 2, it goes there, and 5 has nothing, so it will return back. Okay, and since we have done checked one side, the depth of one side of the 2, we will check the second depth. It is 4, and since 4 also has no depth in it, we'll go back. Now 2 has traversed both the depth. Now it will go back to 1. Now 1 will check for the next depth, that is 3. Then 3 will go to 4, and 4 again has nothing. Again it will return back to 3, and 3 goes to 6. 6 has nothing. It goes back to 3, and at last 3 goes back to 1. Okay. But there is a catch here. Okay. Since 4 was already traversed, so 3 cannot go here. 3 checked if 4, 3 goes to 4. Okay, it checked if it is traversed or not. It was traversed, so it will not count it in our DFS. Okay, so that we will see how can we do that, right? So let us create. Okay, so since I have talked about that if it is visited or not, so we can uh, get one infusion from it that we need one visited array, similarly like we used to create in our DFS, right? So let's say this is our visited array 0 1 2 3 4 5 and 6, and we can create 0 1 2 3 4 5 and 6, right? This, okay, right. Now I'm not creating the adjacency list right now. Okay, we can just traverse using the graph itself. So let's say this is our starting node. Okay, and I'll start the DFS from here. Okay, so initially all the nodes are not visited, right? Okay, and one thing, since you saw that in DFS, let's say this is our 3-year graph. In DFS, in each node we are going into the depth. We are going here, again we are going into its depth. So one more intuition that you might have got, and again after it was nothing in the depth, so it returned back. So you can think of that it is making use of recursion, right? So it's clear that you can make use of recursion. So from here I'll start. Let's say this is our DFS method. It has start, number of vertices, or say visited, right? And an index. Okay, start is here only. This is our visited array, right? So we call DFS here for start, and inside it what we did, this after calling start, we say that mark it as visited. So we visited start as sorry, we marked start as visited. 0 is marked as visited. Now we go to one side depth. So let's say 0 goes to 2. Okay, so 2 is marked. Okay, and one more thing, in the DFS list, we will make use of the list also to store our DFS order of traversal, right? We also have DFS list or array. It goes to 2, the 0 is added in our DFS traversal. DFS. It goes to 2, 2 goes to 1. Okay, before that 2 is marked as visited, and 2 is added in our DFS list. Then 2 goes to 1. Okay, how it goes to 1? We need to call the DFS method inside the DFS method, right? That is how recursion works. 2 calls 1. 1 should be marked visited. Okay, if it is not visited, then only it should be marked visited. And then we'll add 1 in our DFS list, right? And then after 1, 1 will go to its depth. Since 2 is since 0 is already visited, so it will not touch it. It will come back, it will return, then it will go to its next depth. Let's say 4. 4 is unvisited, it will mark it as visited, and add 4 here. A 4 will go to its depth, that is 5. It is not visited, it will mark it as visited and add 5 in the DFS list. A 5 can go either 1, let's say it goes to 6, right? 6 is not visited, mark it as visited, add 6 here. Now 6 goes to, let's say 3, right? And 3 is also not visited, mark as visited, add 3 here, right? Now coming to 3, 3 will go to one of its neighbor. Let's say it goes to 5. 5 is visited, so it will come back. Now it goes to next depth, that is 0. 0 is also visited, it will come back. So it has 3 has checked for all its depth, means all its neighbors, so it goes back to 6. Now 6 has checked for 3 and 5 was its parent already, so it will return back to 5. 5 is checked for only 6, so it will go for its next neighbor, that is 3. 3 is visited, it will come back. 1 is also visited, it will come back, and simply it will return to 4. Similarly 4 will return. Similarly 1 will come there and check it, it will return. Again it will return to 2, 2 will return to 0, right? And at last we will have this as our DFS order. Okay, if you can check 0, 2, 1, 4, 5, 6, 3, in a depth wise manner we are going, not in a level wise manner, right? And the answer can vary according to your code. It can be 0, 1, 0, 1, 2, 4, 5, 6, 5, 3, 6, right? It can vary. All DFS, it is not necessary that a DFS order should be always equal. It depends on your graph and also on your code. Okay. So how will we write our DFS code? Okay. So now, sorry, DFS code. For DFS, what we have, we will have DFS will return we'll have the DFS method. Inside it, we will pass our adjacency list, visited array, and an index. Okay, index or let's say, okay, index of the current node, right? And what we will do, as we got index, so we will mark visited of index as true. The thing that we did here, we got s, we marked it as true. and added it in our DFS list, right? Okay. Okay. It is not two, and okay, this is also pass DFS list. It is a list. We say DFS dot add efficiency dot get index. Simply we can say DFS dot add index, right? And then we will check for its neighbors, right? So for integer neighbor in add efficiency dot get index. If it is not visited, then only we will traverse, right? The thing that we did above. If visited, if it is not visited, then only we will call the DFS function inside it. DFS of efficiency, then visited, then in place of index, what we will pass this our neighbor, and then DFS list, right? And this will eventually give you a DFS order. Okay, I hope this is quite simple. It is very simple. It is very simple. This thing is already required. This thing is say this thing is already required. Okay, this we know that we are adding in our list the answer. It is, or we can say DFS. In case of DFS, we can say answer. Okay, and this we were already doing in our DFS traversal. Okay, so these three lines we cannot consider only as a part of, like as a new topic. Only this thing, if it is not visited, then we will call our DFS. So it is boiled down to two line of code. Okay, so DFS is a two line of code. Okay, this visited was in our DFS only. Okay, this add answer dot add the current index that we were doing only. This for loop we have to traverse. Okay, and at last we are doing this, the main thing, condition, this one. Okay, so I hope DFS traversal was very easy to understand. Okay, thank you for watching. You can try out few code using DFS in your local system also. Okay. Thank you.